3 steps to selecting the right AC drive. This is step 2, selecting the proper rating. In a typical application, you can control a 1 horsepower motor with a 1 horsepower drive. But there are some cases where the application type and environmental conditions warrant derating of the drive, requiring a drive larger than the typical application. We will be using 2 scenarios for selecting the proper rating. Scenario 1 will be using a GS2 series AC drive. Scenario 2 will be using a Durapulse AC drive. The motor full load amperage is required in determining the correct AC drive size. The full load amp rating can be found on the motor nameplate. For Scenario 1, we'll be using a 5 horsepower motor rated at 6.5 full load amps with the following application and environmental factors. For Scenario 2, we'll be using a 7.5 horsepower motor rated at 10.7 full load amps and the following factors. Many applications experience temporary overload conditions due to starting requirements or impact loading. Most AC drives are designed to operate at 150% overload for 60 seconds. If the application requires an overload greater than 150% or longer than 60 seconds, the AC drive must be oversized. Applications that require replacement of existing motor starters may require up to 600% overload. There are 3 different conditions used to calculate the overload requirements. 1. If the overload is less than 150% for less than 60 seconds, divide by its value, which should always equal 1, then multiply by the motor full load amps. 2, which fits Scenario 1, if the overload is greater than 150% for less than 60 seconds, divide the overload by 150, which equals 1.33, and multiply by the motor full load amps of 6.5, giving an overload result of 8.66 amps. 3, which fits Scenario 2, if the overload is longer than 60 seconds, divide the overload by 100, which equals 1.35, and multiply by the motor full load amps of 10.7, giving an overload result of 14.44 amps. AC drives rely upon the cooling properties of air for cooling. As the altitude increases, the air becomes less dense. This decrease in air density decreases the cooling properties of the air. Therefore, the AC drive must be oversized to compensate for the decrease in cooling. Most AC drives are designed to operate at 100% capacity up to altitudes of 1,000 meters. Above 1,000 meters, the AC drive must be derated. Use the following calculations to adjust for altitude. If the altitude is less than 1,000 meters, enter 1, then multiply by the overload result. For Scenario 1, the altitude result is 8.66 amps. If the altitude is greater than 1,000 but less than 3,000 meters, enter 1 and add the result of altitude minus 1,000 multiplied by 0.0001, which is the same as 1% per 100 meters over 1,000. Multiply the result, in this case 1.01, by the overload result. For Scenario 2, the altitude result is 14.58 amps. AC drives generate a significant amount of heat and will cause the internal temperature of an enclosure to exceed the rating of the AC drive, even when the ambient temperature is less than 40 degrees Celsius. Enclosure ventilation and/or cooling may be required to maintain a maximum internal temperature of 40 degrees Celsius or less. Ambient temperature measurements and calculations should be made for the maximum expected temperature. Reducing the carrier frequency on AC drives generally lowers the operating temperature, which will help prevent overheating. Use the following calculations to adjust for maximum enclosure internal temperature. 1. If the enclosure temperature is less than 40 degrees C, as in Scenario 2, and using any series AC drive, multiply the altitude result by 1, which makes the MEIT result 14.58 amps. 2. If the temperature is greater than 40 degrees C but less than 50 degrees C, and using a GS series AC drive up to 5 horsepower, as in scenario 1, multiply the altitude result by 1, which makes the MEIT result 8.66 amps. 3. If the temperature is greater than 40 degrees C but less than 50 degrees C, and using a GS series AC drive greater than 5 horsepower or any Durapulse AC drive, multiply the altitude result by 1.2. For the GS2 series, the adjusted rating is 8.66 amps. According to the specification chart, a 5 horsepower drive rated output current of 8.2 amps is not sufficient for our application. Therefore, we will use a 7.5 horsepower drive rated at 13 amps. For the Durapulse drive, the adjusted rating is 14.58 amps. According to the specification chart, a 7.5 horsepower drive rated output current of 13 amps is not sufficient for our application. Therefore, we will use the 10 horsepower drive rated at 18 amps. So as we can see, there are important factors to consider when selecting an AC drive. 1. The full load amp rating of the motor. 2. The overload requirements of the motor. 3. The installation altitude. And 4. The maximum enclosure internal temperature. We're now ready for step 3, selecting the accessories.